So we just finished chapter 15 when we looked at the Protestant Reformation and absolutism, monarchs across Europe. We're going to jump forward to chapter 18 and look at the scientific revolution, the Enlightenment, and intellectual movements that will lead to revolution and that will challenge the absolutism that we looked at in chapter 15. So let's start looking at these intellectual movements. And we're not going to look at the Renaissance in too much detail because we have a lot of history to get through, and hopefully your patterns teacher looked at it. But we want to start with the Renaissance because it reintroduces Europe to humanism, this idea of the Greeks, of Socrates, Plato, Aristotle, that humans through reason can know things about nature and the universe and do not have to rely solely on the gods or a monotheistic God that we'll see later. So the Renaissance is really important because, again, it returns to Greek humanism and thinking. And that leads to the scientific revolution. Really, really important. And where we're headed, ultimately, I said, is revolution and overthrowing these absolute monarchs. But where we're going to head tomorrow is the Enlightenment. So I want you to know that in terms of chronology of these intellectual movements, we're going to start with the Renaissance, but we're going to focus today on the scientific revolution, and we're going to get to the Enlightenment. But before we get to the Enlightenment, we have to look at the important scientists that move us and Europe and the world intellectually to that point. And where we're going to start is Copernicus. Well, before Copernicus, let's start with Ptolemy. Ptolemy is heavily influenced. He's in very, very early Egypt and the beginning of the Common Era. And he's an astronomer that's influenced heavily by Aristotle. Remember the Greeks and Aristotle and humanism? And he's going to put forth a system called the geocentric theory. So I'm just going to write geocentric, but no, I'm not. I'm going to write theory as well. So geocentric theory, and that's pictured right here, the geocentric theory. And it's in Latin, but I think you can kind of interpret and make out that it is a system of the universe that is based on the Earth being in the center, centric, geo-Earth centric. So the Earth is in the center of the universe, and all of the other heavenly bodies, Mars, Mercury, Venus, Saturn, all orbit Earth. Earth is in the center. Very kind of egotistic. We are the center and everything is orbiting around us. And if you don't have technology, that does make sense. Doesn't it seem like we are still? And if you look up at the night sky, it seems like things are orbiting around us. If you look at the placement of the sun during the day, it moves and it does seem like we are still. And again, with our own human egos, we are the center and everything is orbiting around us in the solar system. So that was accepted by Europe for a long time. And when I say Europe, really the intellectuals of the Catholic Church. So that's important. The Catholic Church is firmly behind the geocentric theory. But then we have a Polish mathematician, astronomer named Copernicus. And it's interesting. So astronomy and math are going to lead the charge in the scientific revolution. Okay, astronomers and mathematicians. Copernicus, mathematician and astronomer, is going to disagree with Ptolemy and the geocentric theory. Boom. It is not the Earth that is the center of the universe. It is the sun. And that means we go from geocentric to heliocentric, sun-centered universe. And so in terms of this schematic that you see here, you would just replace the Earth with the sun, and everything is pretty much the same. Copernicus knows this is going to be a huge deal, especially for the Catholic Church, this institution that is so powerful intellectually across Europe. And in his book in 1453, the same year that Constantinople is going to fall to the Ottomans, he's going to propose in his book on the revolutions of heavenly bodies that there is a heliocentric theory. And in the introduction, he's going to apologize to the Pope because he knows that this is going to bring frustration and attention to their erroneous belief that the earth is the center. So he poses that, and it does create some intellectual chaos for the church. And remember, what else are they dealing with about this same time? They're dealing with another revolution, the Protestant Reformation. So there's religious kind of attacks on doctrine, Protestant Reformation, Martin Luther, and there's also these intellectual science challenges. So the church is really dealing with many challenges in the periods of the 15th and 16th century. We still don't know that even though Copernicus is right about sun-centered, heliocentric, he's not correct about how the planets are orbiting the sun, including the Earth. He believed, like Ptolemy, that they traveled in these circular crystalline spheres, this like crystalline that we can't see sphere, and they were circular orbits. We know that's not the case, so we're going to start with Copernicus. Johannes Kepler, another astronomer, another mathematician, is going to use mathematics to prove that these bodies are traveling in elliptical orbits. And he's going to use math to prove it. And he's going to use the data of one of his teachers, Tycho Brahe, who would go out every night of his life and record the movements of heavenly bodies in the night sky. Kepler uses all of that data to prove mathematically that we don't have circular orbits, but we have elliptical orbits of these bodies around the sun. And we keep going with more and more challenges. Galileo, Magnifico, he's just a... Galileo is going to use technology. Again, we have with Renaissance and more technological, we have competition in Europe and innovation, technological innovation, ingenuity, the telescope. And what Galileo is going to see is that the surfaces of the moon and the sun are not perfect. They are basically made of the same material that the earth is, matter. And the church believed that these bodies were perfect because God made them, but through the telescope, Galileo shows there are mountains, there are valleys on the moon, there are sunspots, different areas of temperature that will darken on the sun, and these bodies aren't perfect. And this is a big challenge to the church. And Galileo, is actually going to be called in front and put on trial for his beliefs during the Inquisition. The Inquisition was mostly trials that were held to root out heresy, non-believers in the Catholic doctrine, heretics. And so Galileo is going to be hauled in front of one of these trials, and he's basically given the choice. Either you can recant your beliefs, take them back, or continue confirming them and you will be executed. But if you recant and take them back, you're going to live. So Galileo has an existential question that he must answer, and ultimately, what does he do? Recant or fight for his beliefs? He recants and lives the rest of his life under house arrest in Florence, but he lives. Okay, so we have Galileo, again, showing evidence for Copernicus and evidence against the Catholic Church and their belief on how the solar system is oriented. Finally, who do we really need? So we've got sun-centered Copernicus, we've got elliptical motion Kepler. We know that the bodies are made of the same matter as Earth with Galileo, intellectual challenge, court, Inquisition. Sir Isaac Newton and that apple falling on his head, gravity. Because people could still say, there's no way that we are orbiting the sun, because if we were, we would be moving at high speeds and everyone would be flying off the surface of the Earth. Doesn't that make sense if you don't have the technology and whatnot, just through your senses and what you experience every day? It does seem like if we were orbiting the sun that we would probably have issues with like staying on the surface of the Earth, because the Earth would be careening through the universe. Anyways, Newton proposes universal gravitation, that all bodies have a force and attraction, and that this force keeps a force on objects to keep them on the ground. So that is important, that there is a reason why we're not flying off the surface of the Earth, gravity, and that also further helps Kepler's elliptical mathematical explanation of planetary motion. So Newton helps Kepler with planetary motion. All right, so these four contributions, Copernicus, Kepler, Galileo, Newton, are really at the crux of the scientific revolution. So now, this is important alert. We understand nature. We understand the universe through mathematics and reason. Everyone, this is monumental. This is super important. Humans understand the universe through reason, math. And if they are able to understand it, who does that take out of the equation of the understanding of the universe and nature? God and the Catholic Church. So a really, really important transition from why does this happen in nature? Because of God. This is how people always explained it, God or the gods. And now we can say this happens because of these natural rules, and this mathematics will explain it and reason. So very, very important. Okay, and next, this is the super important transition. If we understand nature through reason, then we can understand us. We can understand society. If there are universal laws governing nature and the universe, there must be universal laws that also govern politics and economics and social laws, political laws, and that's where we're headed. And those Enlightenment thoughts that there are laws that are universal that can pertain to our human lives every day and our interactions in society and politics and economics, that's really, really powerful. Because if we believe there are, then that's going to challenge the political system and absolute monarchs, these laws of society and politics and economics. And that's where we're headed, to understand what is going to be proposed by John Locke and Voltaire and Thomas Hobbes and Diderot and these important Enlightenment philosophers who are going to challenge the absolute order and lead to revolution.